In this video, we're going to review fractions. So let's start with this problem. Let's say we have 3 over 5, and we wish to add it to another fraction, 1 over 5. What's the sum of these two fractions? If the denominator of the two fractions are the same, you can simply add the numerators of the two fractions. So 3 plus 1 is 4, so this is 4 over 5. So let's say if we have 7 over 8, and we want to subtract it by 3 over 8. Since these two are the same, we can go ahead and subtract 7 by 3. 7 minus 3 is 4. So we get 4 over 8. Now 4 over 8, we can simplify this fraction. We can reduce it. 4 is the same as 4 times 1. 8 is 4 times 2. If we cancel a 4, then we get this fraction, 1 over 2. So that's the answer to the second problem. That's 7 over 8 minus 3 over 8. Now what about adding two fractions with unlike denominators? Let's say if we want to add 7 over 5 with 1 over 4. How can we do this? In order to add two fractions with unlike denominators, you need to adjust the fractions to get common denominators. So we need to find the least common multiple of 5 and 4. Multiples of 4 are 4, 8, 12, 16, 20, and so forth. Multiples of 5 are 5, 10, 15, 20, 25, 30, and so forth. And the common multiple here is 20. 20 is the least common multiple of 5 and 4. If we were to continue this, another common multiple will be 40. But 40 is not the least common multiple. So we want to get the denominator to 20. In order to do that, we need to multiply the first fraction by 4 over 4, and the second one by 5 over 5. 4 times 7 is 28. 4 times 5 is 20. And then we have 5 times 1, which is 5. And then 5 times 4, which is 20. So now that we have the same denominator, we can go ahead and add the numerators of the two fractions. So 28 plus 5 is 33. The final answer for this problem, it's 33 over 20. Now what about this problem? What's 3 over 4 minus 2 over 7? Feel free to try that. So we need to get common denominators. We could use any common multiple of 4 and 7. We could use the least common multiple or the next higher common multiple. One way to quickly get a common multiple in 4 and 7 is simply to multiply the two. 4 times 7 is 28. So we want to get a common denominator of 28. So we're going to multiply this fraction by this number, that is by 7 over 7. And we're going to multiply this fraction using this number, that is by 4 over 4. Seven times 3 is 21. 7 times 4 is 28. 2 times 4 is 8. And 7 times 4 is still going to be 28. So now that we have the same denominator, we can subtract 21 by 8. 21 minus 8 is 13. So the final answer is 13 over 28 for this problem. Now let's work on an example with 3 fractions. So let's say we want to add 1 over 3 plus 2 over 5. And then minus 3 over 4. Go ahead and combine those 3 fractions. So what we need to do is we need to get common denominators. If we multiply 3 by 5 by 4, we can get a common multiple of the three fractions. 5 times 4 is 20. 20 times 3 is 60. So we want to get a common denominator of 60. 60 divided by 3 is 20. So I'm going to multiply this fraction by 20 over 20. 60 divided by 5 is 12. So I'm going to multiply this fraction, the top and the bottom, by 12. And 60 divided by 4 is 15. So I'm going to multiply this fraction by 15 over 15. So here I have 20 times 1, which is 20, and then 20 times 3, that's 60. Next I have 2 times 12 is 24. And we know 12 times 5 is 60. And then 3 times 15 is 45. 4 times 15 is 60. So now we can add 20 plus 24, that's 44. And then 44 minus 45 is negative 1. So the final answer is going to be negative 1 over 60. So that's what you can do if you need to add or subtract 3 fractions. Let's try another example. So let's say we have 2 over 3, and then plus 1 over 2 minus 3 over 4. So go ahead and combine those 3 fractions. So we need to get common denominators. If we multiply 3 by 2 and by 4, 3 times 2 is 6, 6 times 4 is 24. So 24 is a common multiple of these 3 numbers. It's not the lowest common multiple, but it is a multiple of those 3 numbers. The lowest common multiple, it turns out, is 12. 12 is divisible by 3, 2, and 4. So let's get a denominator of 12 for each of these 3 fractions. 12 divided by 3 is 4. So we're going to multiply this fraction by 4 over 4. 12 divided by 2 is 6. So we'll multiply this one by 6 over 6. And 12 divided by 4 is 3. So we'll multiply this one by 3 over 3. So here we have 4 times 2, which is 8. 4 times 3 is 12. Next we have 6 times 1, which is 6. 6 times 2 is 12. And then 3 times 3 is 9. And on the bottom, 4 and 3, we know it's 12. So now let's add the numerators of the fractions. 8 plus 6 is 14. 14 minus 9 is 5. So the final answer for this problem is 5 over 12. Now let's try an example where we're adding or subtracting a combination of 4 fractions. Go ahead and try that. What's 1 over 4 plus 2 over 5 minus 1 over 3 plus 5 over 6? So what number goes into 4, 5, 3, and 6? We need to find a common denominator. A quick and simple way is to multiply all of these numbers. But if we do, we're going to get something pretty big. I would go with 60. 60 is divisible by 6, 3, 4, and 5. Now, if you're wondering how I got 60, well, here's how you can do it. If we were to multiply 4 and 5, that would be 20 times 3 is 60, times 6 is 360. 360 is a common multiple of all 4 of those numbers. What we need is a smaller number that contains the factors of 4, 5, 3, and 6. Factors of 4 are 2 and 2. 5, you can write that as 5 and 1, but I'll just leave it as 5. 3, I'm not going to break it up. 6, that's 3 and 2. Now notice that we really don't need to use the 6 here because we already have a 2 and a 3, which will give us 6. So if we multiply these four numbers, that result is going to be divisible by 4 because it has 2 times 2 in it. It's going to be divisible by 5 because it has a 5 in it. It's divisible by 3 because it has a 3 in it. And it's divisible by 6 because it has 2 times 3, which is 6 in it. So we don't need to multiply by this extra number because we already have a 6 in this number. 2 times 2 is 4, times 5 is 20, times 3 is 60. So that's why 60 is the least common multiple of 4, 5, 3, and 6. It's because within 60, you have factors that will multiply to any one of these numbers. So that's how you can get 60 without writing out all the multiples of each number. So now that we know that 60 is the common denominator that we're trying to get, let's go ahead and get it. 60 divided by 4 is 15. So we're going to multiply this fraction by 15 over 15. 60 divided by 5 is 12. So we're going to multiply this one by 12 over 12. 60 divided by 3 is 20. And 60 divided by 6 is 10. So we'll multiply this one by 10 over 10. So here we have 15 times 1, which is 15. And then 12 times 2 is 24. All of the denominators will be 60. 1 times 20 is 20. And then 5 times 10 is 50. So now what we need to do is add. So let's add this one at a time. 15 plus 24, that is 39. Negative 20 plus 50, or 50 minus 20, that's positive 30. 39 plus 30 is 69. So we get 69 over 60. 69 is 23 times 3. 60 is 20 times 3. So we can cancel a 3, and we'll be left with 23 over 20. So this is going to be the sum of the four fractions. That's the final answer. Now let's move on to our next topic. Let's talk about how we can multiply two fractions. So what's 4 over 3 times 5 over 7? If you see this dot or an X, it indicates multiplication. In order to multiply two fractions, all you need to do is simply multiply across. 4 times 5 is 20. 7 times 3 is 21. So that's how we can multiply two fractions. So the final answer for this problem is 20 over 21. Now let's try another example. Let's say we have 5 over 9, and we wish to multiply it by, let's say, 7 over 8. Go ahead and try that. So this is going to be 5 times 7, which is 35, divided by, and 9 times 8 is 72. So our final answer is 35 over 72. Try this. 5 over 8 times, let's say, 10 over 10 over 7. Go ahead and multiply those two. 5 times 10 is 50. 8 times 7 is 56. Now, we have two even numbers in this fraction, which means we could reduce it. 50 is 25 times 2. 56, well, we could say that's 28 times 2. If we cancel a 2, we're left with 25 over 28 for our final answer. Now what about this one? 12 over 27 times 18 over 30. Go ahead and try that problem. Now, if we multiply across, 12 times 18 is going to give us a big number. 27 times 30, that's another big number as well. And then we'll have to reduce two big numbers. That's going to take a lot of work. Instead, it's better if we reduce these numbers now before we multiply and create an even bigger number. 27, we can write that as 9 times 3. 12, we can write that as 4 times 3. 19 can be written as 9 times 2. So notice that we can cancel a 9, and we can cancel a 3. 30, we can write that as 15 times 2. So we can cancel a 2. So all that's left is a 4 on top and a 15 on the bottom. So notice that in this problem, we really didn't need to multiply by anything. All we need to do is break up these larger numbers into small numbers and cancel. So that's the answer, 4 over 15. Let's work on another example. So let's say we have 18 divided by 45 times 40 over 42 times 35 over 24. Go ahead and multiply those three fractions. So once again, I recommend breaking down each fraction into smaller numbers and cancel as much as you can before multiplying anything. So 45, we can write that as 9 times 5. 18, we can write that as 9 times 2. 40, we can write 40 as 5 times 8 if we want to. 42, we can write that as 6 times 7. 35 has a 7 in it, we can write that as 7 times 5. And 24 has an 8 in it, so we can write that as 8 times 3. We can cancel an 8. We can cancel a 7. We could cancel a 5. Let's put that in a different color. And we can cancel a 9. So right now we have 2 times 5, which is 10. And we have 6 times 3, which is 18. Now we could still reduce this further. 18, we can write that as 9 times 2. 10, we can break that into 5 and 2. So we can cancel the 2's, and thus we're left over with 5 over 9. So that's the answer for this problem. Now let's talk about dividing two fractions. So let's say we have 15 over 40, and we wish to divide that by 35 over 56. How can we do this? Perhaps you heard of the expression keep, change, flip. What it means is that you need to keep the first fraction. So we're going to keep it the same way. You need to change division to multiplication. And then you need to flip the second fraction. So keep, change, and then flip this fraction. So now we converted a problem where we're dividing two fractions into one where we're now multiplying two fractions. So let's break up these fractions into smaller numbers. 35, the only way we can break that up is into 7 and 5. 56, we know that's 7 times 8. 40 is 8 times 5. And 15 is 5 times 3 or 3 times 5. So we can cross out an 8. We could cancel a 7. And we can cancel a 5. So we're left with 3 over 5. And so that's it for this problem. Now let's try another example. So let's say we have 28 over 24 divided by 35 over 32. Go ahead and try that. So let's keep the first fraction the same. Let's change division to multiplication, and then we're going to flip the second fraction. Keep, change, flip. Now let's break up these fractions into small numbers. So 35, that's the only option we have with that is 7 and 5. 28 has a 7 in it, so we can write that as 7 times 4. So the 7's will cancel, which is good. 24 has a 4 in it, so we can write that as 6 times 4. Now 32, we can write that as 8 times 4, or we can write that as 16 times 2. For now, let's leave it as 32. On the bottom, we have 6 and 5. So right now we have 32 over 30. 32 is 16 times 2. 30 is 15 times 2. So at least we can cancel the 2's. And so we're left with 16 over 15. So that's the final answer. So that's what our original expression is equal to. Now what about this one? Let's say if we have a whole number and we wish to divide it by a fraction. So what is 8 divided by 3 over 4? How can we divide a whole number by a fraction? What we can do is we can turn the whole number into a fraction. 8 is the same as 8 over 1. So what we really have is 8 over 1 divided by 3 over 4. And now we can evaluate this the way we've been doing it before, using keep, change, flip. So let's keep the first fraction the same. Let's change division to multiplication, and then we're going to flip the second fraction. So now we can multiply across. So we have 8 times 4, which is 32, and on the bottom, 1 times 3, which is 3. So that's going to be the answer. It's 32 over 3. Now what about taking a fraction, let's say 5 over 7, and dividing it by a whole number? What's 5 over 7 divided by 6? So we can rewrite 6 as a fraction. We can say it's 6 over 1. And then using keep, change, flip, we'll keep the first fraction the same. We'll change division to multiplication, and then we'll flip the second fraction. So it becomes 5 times 1, which is 5, and 7 times 6, which is 42. So the answer is going to be 5 over 42. Now what would you do if you saw a fraction that looked like this, a complex fraction? 5 over 3 divided by 7 over 6. How can we solve this one? What this really means is we're taking the first fraction, 5 over 3, and then this fraction here means division. We're dividing it by the second fraction, 7 over 6. So it's another way to write this expression. So using keep, change, flip, we'll keep the first fraction the same. We'll change division to multiplication, and then we're going to flip the second fraction. So 5 and 3, we can't really break that into small numbers. But 6, we can break up 6 into 3 times 2. So we can cancel a 3, and then we'll be left with 5 times 2, which is 10. And we only have a 7 on the bottom. So this is the final answer. It's 10 over 7. Now let's talk about how we can convert an improper fraction into a mixed number. An improper fraction is a fraction where the numerator is greater in value than the denominator. So 17 over 5 is an improper fraction. How can we convert this into a mixed number? So here's how you can do it mentally. How many times does 5 go into 17? 5 goes into 17 3 times. The denominator is not going to change. 5 times 3 is 15. And 17 minus 15 is 2, so the remainder is 2. Thus 17 over 5 is 3 2/5 as a mixed number. Let's try another example. 29 over 7. How many times does 7 go into 29? 7 goes into 29 4 times. 4 times 7 is 28. 29 minus 28 is 1. So the answer is 4 1/7 as a mixed number. So that's how you can do it mentally. For those of you who want to show your work, here's what we can do. 17 over 5, we can break that into 15 over 5 and 2 over 5. The reason why I chose 15 is because 5 goes into 15 evenly. 15 over 5 is 3, and then we have 3 plus 2 over 5, which is 3 2/5 as a mixed number. So that's a quick way to show your work. For the other one, where we had 29 over 7, we can write that as 28 over 7 plus 1 over 7. 29 is 28 plus 1. 28 divided by 7 is 4. So we get 4 plus 1 over 7, which is 4 1/7. Go ahead and try these examples. Convert these fractions into mixed numbers. 23 over 5. Try 14 over 9. And also 28 over 6. So for the first one, I would break up 23 into 20 and 3. 5 goes into 20. 20 divided by 5 is 4. So we get 4 plus 3 over 5. So we can write that as 4 3/5. 14 over 9, we can write that as 9 over 9 plus 5 over 9. 9 over 9 is 1, and so this becomes 1 5/9. Now how can we break up 28? What I would do is I would choose the highest multiple of 6, just under 28. Multiples of 6 are 6, 12, 18, and 24. 30 is too high. So we have 24, and then 28 minus 24 is 4. So I would break up 28 into 24 plus 4. 24 divided by 6 is 4. And 4 over 6, we could simplify that fraction. 4 is 2 times 2. 6 is 3 times 2. So we can cancel a 2. And so we're left with 4 plus 2 over 3. Thus the final answer is 4 2/3. So now you know how to convert an improper fraction into a mixed number. Now what about going the other way? What if we had a mixed number? How can we convert the mixed number into an improper fraction? So first, rewrite the denominator. Next, multiply these two numbers. 3 times 3 is 9, and then add the numerator. So we got 3 times 3 is 9, plus 2 is 11. The answer is going to be 11 over 3. Try this one. Convert 5 1/4 into an improper fraction. So it's going to be 5 times 4, which is 20, plus 1. So that's going to be 21 over 4. Try these two. 7 3/8, and then 2 4/5. So first, let's write the 8, and then it's 7 times 8, which is 56, plus 3, and that's going to be 59. For the next one, let's rewrite the 5. 2 times 5 is 10, plus 4, that's 14. So it's going to be 14 over 5. So that's how you can convert a mixed number back into an improper fraction. Now, how can we add two mixed numbers? So let's say if we have 3 1/4 plus 5 2/3. How can we add these two mixed numbers? Well, first, let's rewrite it. 3 1/4, we know it's 3 plus 1 over 4. 5 2/3 is 5 plus 2 over 3. So we can add 3 and 5 together, and we're going to get 8. And then we have 8 plus 1 over 4 plus 2 over 3. Now what we need to do is we need to add those two fractions together. And in order to do that, we have to get common denominators. So we're going to multiply this one by 3 over 3, and this fraction by the other denominator, 4 over 4. So we have 8, and then plus 1 times 3 is 3, 4 times 3 is 12. And here we have 2 times 4, which is 8, over 3 times 4, which is 12. 3 over 12 plus 8 over 12 is 11 over 12. So thus we have 8 plus 11 over 12. Thus we can write the final answer as 8 and 11/12. So that's how we can add two mixed numbers together. Try this one. 4 3/4 plus 3 1/5. Feel free to pause the video. Go ahead and add those two mixed numbers together. So first, let's rewrite the problem. 4 3/4 is 4 plus 3 over 4. 3 1/5 is 3 plus 1 over 5. So now let's combine the whole numbers. 4 plus 3 is 7. And then we have plus 3 over 4. And then plus 1 over 5. So 3/4, let's multiply by using the 5. So we're going to multiply 3/4 by 5 over 5. And we're going to multiply 1 over 5 by the other denominator, 4. So times 4 over 4. So this is going to be 7 plus 3 times 5 is 15. 4 times 5 is 20. And then this is 4 over 20. So now we can add these two fractions. 15 over 20 plus 4 over 20, that's going to be 19 over 20. So the final answer is 7 19/20s. I mean 7 and 19 over 20. Now let's work on an example where we need to subtract two mixed numbers. So 5 2/7 minus 3 3/4. Go ahead and try that example. So we can rewrite this as 5 plus 2 over 7, and then minus, this is 3 3/4, but we need to distribute the negative sign to both the 3 and the 3/4. So here we have 5 minus 3. 5 minus 3 is 2. And then we're left with positive 2 over 7. And then negative 3/4. So now let's combine these two fractions. We're going to multiply this fraction by 4 over 4. And we're going to multiply this fraction by 7 over 7 to get common denominators. So it's going to be 2, and then it's plus. This is 2 times 4 is 8, 7 times 4 is 28, So it's 8 over 28, and then minus 3 times 7 is 21, and that's going to be over 28 as well. 8 minus 21, that's a negative 13. So we got 2 minus 13 over 28. So what can we do here? What we're going to do is we're going to borrow a 1 from the 2. So I'm going to write 2 as 1 plus 1. This one, I'm going to convert it into 28 over 28. A number divided by itself is 1. So we have 1 plus, and then we're going to change this. So basically what I'm doing is I'm multiplying this one by 28 over 28. So it becomes 28 over 28. But it still has the same value as 1. So now we can combine these two fractions. 28 minus 13 is 15. So the final answer is going to be 1 and 15 over 28. So that's how we can subtract two mixed numbers. Let's try another example. So let's say if we have 7 and 1/8, we wish to subtract that by 3 and 4/5. Go ahead and try that. So let's begin by rewriting the problem. This is 7 plus 1 over 8, and then it's minus 3, and then minus 4 over 5. Don't forget to distribute the negative to the 3 and the 4 over 5 as well. So now let's combine the whole numbers. 7 plus negative 3, and that's going to be positive 4. And then we're left with 1 over 8 minus 4 over 5. So let's get common denominators. Let's multiply this fraction by 5 over 5. And let's multiply 4 over 5 by 8 over 8. This will give us a common denominator of 40. So this is 5, and then 8 times 5 is 40. And then it's going to be minus 4 times 8 is 32, and that will be over 40 as well. 5 minus 32, that's going to be negative 27. So we need to borrow a 1 from the 4. So 4, we're going to write that as 3 plus 1. Now this 1, you can write it as 1 over 1. And we're going to multiply it by 40 over 40 to get common denominators. So what we have now is 3 plus 40 over 40. This right here is equal to 4, by the way. And then minus 27 over 40. So 40 minus 27 is 13. We're going to get 3 plus 13 over 40, which means our final answer is 3 and 13 over 40. So now you know how to subtract two mixed numbers and how to leave your final answer as a mixed number as well. Now let's talk about how to multiply two mixed numbers. So let's say if we have 7 and 1/4, and we want to multiply that by 3 and 2/5. How can we do this? What I recommend doing is converting each mixed number into an improper fraction. So for the first one, it's going to be 7 times 4, which is 28, plus 1, so that's 29 over 4. For the next one, we're going to keep the denominator the same, and then we're going to multiply these two numbers. 3 times 5 is 15, plus 2, so that gives us 17. And then all we need to do is just multiply across. 29 times 17, that's 493. And then 4 times 5 is 20. And so this is our answer. It's 493 over 20. And that's how we can multiply two mixed numbers. Now let's try another example. So let's multiply 6 and 4/5 by 7 and 2/3. Go ahead and try that. So let's convert the first mixed number into an improper fraction. Let's begin by rewriting the denominator, and then it's going to be 6 times 5, which is 30, plus 4. That's going to give us 34. And then times, let's write the denominator of the other fraction. This is going to be 7 times 3, which is 21, plus 2, that's 23. And now let's multiply across. 34 times 23. I'm using the calculator for that. And that's going to be 782. And then 5 times 3, that's 15. So the answer is 782 over 15. By the way, for those of you who want to review long multiplication, here's what you can do if you don't have a calculator and you want to multiply those two numbers. So first we have 4 times 3, which is 12. Write the 2, carry over the 1. And then 3 times 3 is 9, plus 1 is 10. So we can write 10 here. Next, put a 0. 2 times 4 is 8. And then 2 times 3 is 6. And then you can add. 2 plus 0 is 2. 0 plus 8 is 8. 1 plus 6 is 7. So that's a quick review of how you can perform long multiplication. Now let's talk about how we can divide two mixed numbers. So let's say we have 5 and 2/7, and we wish to divide that by 3 and 1/4. What I recommend doing is converting each mixed number into an improper fraction. So let's write the denominator first, and then we have 5 times 7, which is 35, plus 2. So this is 37 over 7. For the next one, let's begin by writing the denominator 4, and then it's 4 times 3, which is 12, plus 1, that's 13. So we're dividing these two improper fractions. So we can rewrite it as 37 over 7 divided by 13 over 4. Now using keep, change, flip, we're going to keep the first fraction the same. We're going to change division to multiplication, and then we're going to flip the second fraction. So this is going to be 4 over 13. For some reason, I wrote 4 here. There should be a 7. I don't know why I put a 4. But now what we can do is we can multiply across. So 37 times 4 is 148. And then 7 times 13 is 91. So the answer is 148 over 91. Let's try another example. Let's divide 7 and 4/5 by 3 and 2/7. So feel free to try that. So let's begin by converting each mixed number into an improper fraction. So 5 times 7 is 35 plus 4. That's going to be 39. 3 times 7 is 21 plus 2. That's 23. So what we have now is 39 over 5 divided by 23 over 7. Using keep, change, flip, we're going to keep the first fraction the same. And just like before, we're going to change division to multiplication. And then we're going to flip the second fraction. So now let's multiply across. So we have 39 times 7, which is 273. 5 times 23. 5 times 20 is 100. 3 times 5 is 15, so this is 115. So now you know how to divide two mixed numbers. But you know what? Since the original problem was a mixed number, let's convert this improper fraction back into a mixed number. 115 goes into 273 two times. 115 times 2 is 230. If we subtract 273 by 230, that's going to be 43. So these are the two numbers that I want to break up 273 into. 230 plus 43. Now we know that 230 divided by 115 is 2. So we get 2 plus 43 over 115. And so our final answer as a mixed number is 2, 43 over 115. Now going back to the previous problem, where we had an answer as 148 over 91. Let's convert that into a mixed number as well. 91 goes into 148 one time. So the highest multiple of 91 be below 148 is 91. Now if we subtract 148 by 91, that's going to be 57. So 91 plus 57 is 148. 91 divided by itself becomes 1. So the final answer as a mixed number is 157 over 91. Now let's talk about how to convert a fraction into a decimal. So what is the decimal value of 3 over 4? In order to convert a fraction into a decimal, you could use division. So we're dividing 3 by 4. Now 4 doesn't go into 3, at least nicely. So what we're going to do is we're going to add a decimal point and a 0. Now we're going to treat 3.0 as if it's 30. And we're going to put a decimal point here as well. How many times does 4 go into 30? 4 goes into 30 7 times. If you're not sure about this, what you can do is you can write a list of the multiples of 4. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. The highest multiple of 4 under 30 is 28. And 4 times 7 is 28. So 4 goes into 30 7 times. Or we could say 4 goes into 3.0 0.7 times. 4 times 7 is 28. So 4 times 0.7 is 2.8. If we subtract these two, we're going to get 0.2. And then we're going to add a 0. Now 4 goes into 20 5 times. Now the remainder is 0. The answer is what we have here. 3 over 4 is equal to 0.75 as a decimal. So that's how you can convert a fraction into a decimal. It's by using long division. Let's try another example. Let's convert 7 over 8 into a decimal. Actually, let's say 3 and 7/8. Let's use a mixed number. Let's convert this mixed number into a decimal value. So keep in mind, this is 3 plus 7 over 8. Now, the fractional part, we're going to convert that to a decimal using long division. So we're going to put the denominator on the outside. 8 doesn't go into 7 nicely, so we're going to use 7.0. Now, how many times does 8 go into 70? If you're not sure, you can write out the multiples of 8. And you really don't need to go past 9. The highest multiple of 8 under 70 is 64. So we could say 8 goes into 70 8 times. 8 times 8 is 64, so 8 times 0.8 is 6.4. 70 minus 64 is 6. So 7.0 minus 6.4 is 0.6. Now let's bring down a 0. How many times does 8 go into 60? The highest multiple of 8 under 60 is 56. So we could say 8 goes into 60 7 times. 8 times 0.07, that's going to be 0.56. And now we can subtract 60 by 56. We're going to get 4. And then let's bring down another 0. 8 goes into 40 5 times. And now we have a remainder of 0. So this is going to be the value of 7 over 8. So this becomes 3 plus, we're going to replace this with that number. So it's 3 plus 0.875. So we get 3.875. So that is the value of this particular mixed number. Now, it helps to know the common values of some fractions. 1 over 2 is 0.5. 1 over 3 is 0.3 repeated. 1 over 4 is 0.25. 1 over 5 is 0.20 or 0.2. 1 over 8 is 0.125. And 1 over 10 is 0.1. If you know those, then you can quickly find the value of other fractions. And 1 over 20 is 0.05. So for instance, let's say if we want to find the value of 3 over 4. 3 over 4 is 3 times 1/4. And we know 1 over 4 is 0.25. So 3 times 0.25 is 0.75. So that's a quick and simple way to convert this into a decimal if you want to avoid long division. Let's try another example. Let's say if we want to find the value of 4 over 5. This is 4 times 1 over 5. Now, if you remember that 1 over 5 is 0.2 or 0.20, and 4 times 0.2 is 0.8. So 4 over 5 is 0.8. Now let's say if we want to find a value of 5 and let's say 3/10. This is going to be 5 plus 3 over 10. And 3 over 10, we can write that as 3 times 1 over 10. 1 over 10 is 0.1. 3 times 0.1 is 0.3. So we have 5 plus 0.3, which is 5.3. Now let's try another example. Let's say we have 7 and 3/8. Go ahead and convert that mixed number into a decimal. This is going to be 7 plus 3 over 8. We're going to write this as 7 plus 3 times 1 over 8. And 1 over 8 as a decimal, if you remember, it's 0.125. 3 times 0.125. 3 times 0.1 is 0.3. And 25 times 3 is 75, so this is going to be 0.375. So this is the value of 7 and 3/8. It's 7.375. So that's a quick and simple way to convert common fractions into decimals. Now sometimes you need to be able to convert a percentage into a decimal. So for instance, how would you convert 75% into a decimal? You can either divide 75 by 100 or move the decimal 2 units to the left. Either case, it's 0.75. So with that in mind, go ahead and convert these values, these percentages, into decimals. 146%, 67%, 15%, 8%, 4.2%, and let's say 0.56%, and then 1400%. Go ahead and convert those percentages into decimals. So if we move the decimal point 2 units to the left, this is going to be 1.46. 67% is 0.67. 15% is 0.15. 8%, if you move it 2 to the left or divide 8 by 100, you're going to get 0.08. 4.2% is 0.042. 0.56%, that's 0.0056. 1400%, if you move it 2 units to the left, that is the decimal point, you get 14. So that's how you can convert a percentage into a decimal value. Now, go ahead and convert the following decimal values into percentages. In order to convert a decimal back to a percentage, multiply by 100, or move the decimal point 2 units to the right. So 0.37 is 37%. 0.04 is 4%. 0.0028, if you multiply that by 100, you're going to get 0.28%. 0.465, that's 46.5%. So that's how you can interconvert between decimal values and percentages. But now let's talk about how we can convert a decimal number into a fraction. So let's say we have 0.2. We know that 0.2 is 1 over 5. But how can we show our work to convert this decimal value into a fraction? So notice that this is rounded to the nearest tenth. Therefore, put it over 1 and multiply the top and bottom by 10. 0.2 times 10 is 2. And 1 times 10 is 10. And then all you got to do is reduce the fraction. 2 is 2 times 1. 10 is 2 times 5. So we can cancel the 2, and we're going to get 1 over 5. So 1 over 5 is 0.2. Go ahead and try this one. Convert 0.3 into a fraction. So we're going to put this over 1 and multiply the top and bottom by 10. 0.3 times 10 is 3. 1 times 10 is 10. And we can't reduce this fraction, so it's simply 3 over 10. Now what about this one? 0.24. How can we convert that into a fraction? So like before, we're going to put this over 1. But notice that 0.24 is rounded to the nearest hundredth. So to get rid of the decimal, we need to multiply it by 100 this time. That is 100 over 100. 0.24 times 100. Whenever you multiply a number by 100, move the decimal 2 units to the right. So this becomes 24. On the bottom, we have 1 times 100, which is 100. So now all we need to do is reduce the fraction. So 24, we can write that as 4 times 6. 100 is 4 times 25. We can cancel the 4, and we're left with our final answer, which is 6 over 25. So that's how we can convert 0.24 into a fraction. Try this one, 0.36. So let's put this over 1, and let's multiply by 100 over 100. So 0.36 times 100 is 36, and then 1 times 100 is 100. And now how should we break up these numbers? Well, 36, we can write that as 4 times 9. 100, we can write that as 4 times 25. So the final answer is going to be 9 over 25. Now what about 0.218? What is 0.218 as a fraction? Now this time, this one is rounded to the nearest thousandth. So we're going to multiply it by 1,000 over 1,000 to get rid of the decimal. 0.218 times 1,000 is 218. And 1 times 1,000 is 1,000. Now, if you're not sure how to break up the numbers, if they're both even, you could simply divide by 2. What's half of 218? Half of 200 is 100. Half of 18 is 9. So that's 109. Half of 1,000 is 500. And we can't reduce it any further than this. So the answer is 109 over 500. Now let's try another example, 0.314. Go ahead and convert that into a fraction. So just like before, we're going to multiply by 1,000 over 1,000. 0.314 times 1,000 is 314. Now let's divide by 2. Half of 314. 314 divided by 2 is 157. 300 divided by 2 is 150, and then 14 divided by 2 is 7. When you add 150 and 7, you get 157. And we know half of 1,000 is 500. So this is going to be 157 over 500. Now, how would you convert 0.2 repeating into a fraction? Now, this goes on forever. This is 0.22222, and it keeps on going. How would you convert that into a fraction? 0.2 repeating is simply 2 over 9. 0.4 repeating is simply 4 over 9. 0.5 repeating is simply 5 over 9. 0.3 repeating, this one is 3 over 9, but you can reduce it. If you divide by 3, the top and bottom, this becomes 1 over 3. So 0.3 repeating is 1 over 3. 0.6 repeating, this initially is 6 over 9, but you can reduce that. 6 is 2 times 3, 9 is 3 times 3. So if you cancel a 3, 0.6 repeating reduces to 2 over 3. Now what about 0.23 repeating? So this is 0.23, 23, 23, and so forth. This is 23 over 99. 0.36 repeating. This is 36 over 99. But this one we could simplify. 36 is 9 times 4. 99 is 9 times 11. So we can cancel a 9. Thus 0.36 repeating reduces to 4 over 11. Now what about this one? 0.126 repeating. What can we do with that? So here we have 3 numbers that are repeating. This is going to be 126 over 999. Now how can we reduce 126 over 999? 126 is divisible by 3. 120 divided by 3, or 12 divided by 3 is 4. 6 divided by 3 is 2. So 126 divided by 3 is 42. 999 divided by 3 is 333. And it turns out that we can divide both numbers by 3 again. 42 divided by 3 is 14. 333 divided by 3 is 111. So the final answer is 14 over 111. Let's try another one like that. Let's reduce 0.315 repeating. So first we can write this as 315 over 999. 300 is divisible by 3, and so is 15. Therefore, 315 must be divisible by 3. 300 divided by 3 is 100. 15 divided by 3 is 5, so 315 divided by 3 is 105. And we know this is going to be 333. Now 105, what can we do with that? 105 is also divisible by 3. 105 divided by 3 is 35. 333 divided by 3 is 111. And this is as far as we can go for this example. So it's 35 over 111. Now what about this one? 0.43, but only the 3 is repeating. So this is 0.433333. How can we turn that into a fraction? Well, we need to separate the repeating decimal from the non-repeating part. To do that, subtract. Let's add a few 3's. So this is going to be 0.33333 plus another number. This is the repeating part. What is the other number? The other number has to be 0.1. 0.3 repeating plus 0.1 is going to be 0.4 with 3 repeating. And if you add these two, you're going to get this number. So another way to get this number is to take this number and subtract it by 0.33333. And make sure you end up at the same spot. So let's say if you round this to the 5th digit after the decimal point, you want to stop here at the 5th digit after the decimal point. Because if you add another 3, you're not going to get 0.1. So in your calculator, if you type in 0.433 and then 33 and subtract that by 0.33333, you're going to get 0.1. Now, so let's write the exact values here. So 0.43 repeating is 0.3 repeating plus 0.1. 0.3 repeating, we know it's 1 over 3. 0.1, we know it's 1 over 10. So now we need to combine these two fractions. So let's multiply this one by 10 over 10 and the other one by 3 over 3. So we get 10 over 30 plus 3 over 30. And this becomes 13 over 30. If you type this in your calculator, 13 divided by 30, you're going to get 0.43 repeating. So that's how you can check your work. Let's try another example. Let's say we have 0.6323 repeating. Go ahead and convert this decimal into a fraction. So the repeating part is 0.23. To find the non-repeating part, type this in your calculator, 0.632323, and subtract it by the repeating part. So we have a total of 6 digits after the decimal. So we're going to subtract it by 0.232323, the same number of digits. And you really don't need to use a calculator to see the answer. This part will cancel with this part. So what you're really doing is 0.63 minus 0.23. 63 minus 23 is 40. So we get 0.4. So this is 0.2 repeating, 0.23 repeating plus 0.4. If you just focus on this part here, if you add those two, you get 0.63. So 0.23 repeating is 23 over 99. 0.4 is 4 over 10. So what we need to do now is we need to add those two fractions. So I'm going to multiply this one by 10 over 10 and the other one by 99 over 99. 10 times 23 is 230. The common denominator will be 990. Now 4 times 99. Think of 99 as 100 minus 1. 4 times 100 is 400. 4 times negative 1 is negative 4. So this is 396. And that's what 4 times 99 is. It's 396. So now we need to add 230 plus 396. And so that's going to be 626 over 990. Now we have two even numbers, so let's divide the top and the bottom by 2. 626 divided by 2 is 313. 990 divided by 2. 900 divided by 2 is 450. 90 divided by 2 is 45. 450 plus 45 is 495. So this is going to be the final answer. Now let's work on one more example. Let's say we have 0.5813 repeating. Go ahead and convert this into a fraction. So let's begin by writing the portion that is repeating, that's 0.13. If we subtract 0.58 by 0.13, 58 minus 13 is 45. So the missing part is 0.45. 0.13 repeating, that's going to be 13 over 99. 0.45 is 45 over 100. Now we need to get common denominators. It's better if we simplify this fraction first before getting common denominators, so we can deal with smaller numbers. 45 is 5 times 9. 100 is 5 times 20. So we can reduce 45 over 100 to 9 over 20. We can't reduce that fraction, so we're just going to have to work with what we have now. Let's multiply this by 99 over 99. Let's multiply the first fraction by 20 over 20. 13 times 20. If you have 13 $20 bills, how much money do you have? That's going to be $260. 99 times 20. Let's use a calculator for that. So that's going to be 1980. 99 times 9. That's 891. 891 plus 260 is 1151. So this is our final answer. 1151 over 1980. And we can't really reduce this fraction, so we're going to keep our answer like this.